Hello, today we'll be discussing ratio and proportions, and we're going to start off by talking about some basic theory terminologies. First thing, what does it mean for things to be in proportion? So, proportion essentially what it means is that if you have a quantity A and you have a quantity B, C, and D, it means that the ratio of A by B, if it's equal to C by D, then A, B, C, and D are in proportion. It's a very basic, simple term, and I hope that all of you are already aware of this. And this can further be simplified to AD is equal to BC. Okay. Now, one thing which you guys may not be familiar with is something called continued proportion. And once again, nothing too difficult about it. It's just over here, if you have three terms, A, B, and C, it means that the ratio of A to B is equal to the ratio of B to C. Okay, and this is further simplified to B square is equal to AC. All right. So over here, there are some terms you need to know related to this. Over here, A is called the first proportion, first proportional. B is called the mean proportional, and C is called the third proportional. Okay, now these terminologies are used in the question, so you should know these very well. And another thing that I would like to bring to your attention is that over here we've simplified continued proportional expression to B square equals to AC. Also remember that the geometric mean, like the arithmetic mean between two numbers is their sum divided by two, like their average. But the geometric mean is the product, the root of the product. So if you have two numbers A and C, then their geometric mean is the root over AC. So that's just something I wanted to tell you before we move on. And I think that's enough, and we can start with the questions. So let's just delete all of this. And first question. Okay. So right, like I said, they do use these terminologies, and let's see how we deal with them and how we solve this question. Okay, so they've told us that 6 is the mean proportion between two numbers. So like I said, A was the first proportion, let me just write it down. First proportional, B is the mean one, and C is the third proportional, right? And they've told us that uh, the mean proportional is 6 and between two numbers x and y. So here they've called A x and C as y. And 48 is a third proportional to x and y. Okay, so that's breaks down into smaller parts. 6 is the mean proportion between two numbers x and y. So that means that, as I told you, 6 square is equal to xy, right? Because p square is equal to ac. So we know that x times y is equal to 36, right? Then they've told us 48 is a third proportional to x and y. So now this is the second case, okay? Don't get confused, this is slightly confusingly worded. But now this is the second case, okay? Now they've told us that 48 is a third proportional to x and y. That means that your y is now the mean proportion, right? X, y, and 48. So y is the mean proportion. So like I said, so y becomes b, so it becomes y square is equal to 48x, right? So now you have your two equations, which is xy is equal to 36 and y square equals to 48x. Now you can solve it however you please. Over here, what I would normally do is you find out the value of x as y squared by 48. And once you have this value, then you can simply put this value into the first equation. So you have y squared by 48 times y is equal to 36. So you have a y cube, which is equal to 36 into 48. And now you can break this up. So you know y cube is equal to 12 into 3 into 12 into 4. And you can simply write 3 into 4 as another 12. Just one second. Yeah. So you can simply write this as another 12, right? So then you can write your y as equal to 12. And once you know that your y is equal to 12, your x is simply equal to y squared by 48, which is 144 upon 48. And this is 48 times 3. So x is equal to 3. Let me just verify that once. Yes. Okay. So now we can move on to our Next question, let me just write down the answer ones. X equals to 3, y is equal to 12. Okay, I hope you guys all understood it. I'll just go through what we did once more. So they told us that 6 is the mean proportion between two numbers. Whatever is the mean proportion, that square is equal to the product of the other two numbers. So that means that 6 square is equal to x times y. And then they told us that if x and y are taken as the first two numbers, then 48 is a third proportional to it. That means that y is the mean proportion and y square is equal to 48 times x. And then once we get these two equations, it's simple simultaneous linear equation solving, and you can solve this and you can get your answer. Now let's move on to the next question. Right. Okay. Now we are moving into the slightly more complex kinds of questions. So we've been told that a square plus c square, ab plus cd, and b square plus d square are in continued proportion. Prove that a, b, c, and d are in proportion. So in the beginning of the video, I told you the difference between proportion and continued proportion, and we're going to be using that here. So we've been told that a square plus c square plus ab plus cd plus and b square plus d square in continued proportion. This means that um, so what I tell you, if three terms are in continued proportion, a by b equals to b by c, or b square is equal to ac, right? So over here, what is our b? The second term is this one, right? Oh wait, I think I circled the wrong part. 1 second, yeah. The second term is ab plus cd, right? So that means that ab plus cd whole square is equal to the product of the first term and the third term, a square plus c square times b square plus d square, right? And now once we further simplify this and solve it, we get a square b square plus c square d square plus 2abcd, applying a plus b whole square, which I'm sure you guys already know. And if we simplify this, we get a square b square plus a square d square plus b square c square plus c square d square, right? And now once we simplify this a bit, you get your a square b square cancels out from both sides, and your c square d square also cancels out from both sides. And you're left with, if I take this all to one side, a square d square plus b square c square minus 2abcd equals to 0. Now once again, I take you back to your junior classes. A square plus b square minus 2ab. This is your a minus b whole square identity. So you can simply write this as ad minus bc whole square equals to 0. And then we've done lots of quadratic equations. So I'm sure you know that over here, using the zero product rule, you get AD equals BC. And that is what we had to. Okay, and we had to prove that they're in proportion. And remember, in the beginning of the video, I told you that for two numbers to be in for four numbers to be in proportion, A by B must be equal to C by D. And if you simplify this, you get AD equals to BC, which is exactly what we have gotten. Okay, I hope you guys all understood this. Let's move on to the next question. Okay. Now we've been told that A, B, C are again in continued proportion, and we have to prove this. Okay, so now the questions really start from here on, and these are the questions which you're likely to see in your examinations. A, B, C are continued proportion. So let's just write that down. We know that A by B is equal to B by C, right? Okay, and now whenever you get the proving questions, always, okay, this is a rule that is a given, okay? Always make this equal to a third number called k. So take a constant called k. This is a very important step. We'll be using it in all the questions from now on. Okay, so now if you just assume that the ratio of AB is equal to the ratio of BC, which is given to you, and you said that this is equal to a random number k, okay? So now if you simplify this, you get two equations, right? You get A by B equals to k, and you get b by c equals to k. So that means that you know that a is equal to bk and b is equal to ck, right? Okay. Now that we have that, let's work on our equation. So what is it? And always in the ratio and proportion questions, break down your equation into LHS and RHS. So our LHS here is A by C, right? Now, what have we written A as? A, we've written it as BK, right? And what have we written C as? We've not written C as anything, right? So let's leave it as C. But now, what have we written B as? We've written B as CK. So let's write B as CK once again. So that's CK times K divided by C, right? So now this is simplifies up to K square, right? Let me repeat what I've done right here. A, we've written it as BK, right? Now we've written B as CK. So I've written B as CK, and then you get in CK squared by C, and you can cancel out the C's, and you get K squared. Now let's work on the RHS. Let me just copy down the RHS. That is 2a square minus 5ab plus 7b square. 2a square minus 5ab plus 7b square divided by 2b square minus 5bc plus 7b square. 2b square minus 5, what was it? 2b square minus 5bc plus 7c square. So now how can we simplify this? Let's use our same thing we got up above. We can write a as bk, right? So 2 times bk squared, and we can write 5ab once again minus 5. A we've written as bk. Okay, now here is the next rule I want you to keep in mind. If in a numerator you're changing all the a's, then don't change the b's. Let the b's remain as they are because we want to introduce some familiarity. And if you've written a as bk, we don't want to change back b again to ck. That won't make sense for us. So let's write bk as simply just b and then plus 7b square. Again, we don't change it here because we want everything to be in terms of b and k in the numerator, right? This is that. And then our denominator is 2b square. Over here, let's change all the b's. We changed all the a's on top, we have to change all the b's. Now, you must be wondering why we can't change the c's, because in our original equation here, we've not written c equals to anything. We don't express c as a product of two different numbers. So let's just change the b's here. B is equal to ck, so let's write that down. So 2 times ck whole square minus 5 times ck times the c plus 7c square, right? Now you guys may be seeing a pattern here. Let's break this down and see what it is exactly. So okay, so over here you can see that b square is a common term everywhere, right? Like if I can write this as 2b square k square, right? And if I write this as 2c square k square once, right? Now over here, you can see that b square is there everywhere, right? So let's take out b square out common from the entire equation. If I take b square out common, I have 2k square, right? I have a minus 5k here, and I have a plus 7 there, right? That's the same with the numerator now. Okay, same with the numerator. Over here, let's take out the c square out common because each term has a c square. So if I take c square out common, I have 2k square, and you will see the same term comes again, minus 5k plus 7. Okay, and now you can simply strike these two out, and you get b square by c square. Now, what have we written b as? We wrote b as ck. So we can write b square as ck whole square divided by c square, which is c square k square over c square, and we get k square. So now, we proved earlier LHS equals to k square, which equals to RHS. Proved. Now, different places you learn from different tutors, school teachers, they may all tell you to do different things, but I have done hundreds of these questions over the last year. And trust me, this is, in my opinion, the best way to do it. Every time you're given a ratio proportion question, make your proportion, whether it's continued proportion or normal proportion, equal to a constant k. Then get your values a equals to bk, b equals to ck, or something of that sort. Then if you have a numerator and denominator, substitute either A or B, whichever one, in terms of your constant K, and do the same with the denominator. Cancel the like terms. Do the same for both the LHS and the RHS. and you should not go wrong. These are again on the simpler level, and I expect everyone to get these questions right. Okay, let's move on to the next question now. Right. Okay. This has come in the 2017 board paper. Let's see how it goes. So they told us that B is a mean proportion between A and C. So we know that B square equals to AC. But over here in these questions, it makes more sense to write it in terms of our simple ratio. So, A by B equals to B by C. And once again, make it equal to a constant K. Therefore, A equals to BK and B is equal to CK. Okay, we're going to be using this everywhere. I'm just going to put this in a box. Please always remember to do this step. Okay. Now okay. Now we have to prove something. So let's write on the LHS first. Okay. Once we write on the LHS, okay. So what have we been told? LHS is A4 plus A square B square plus B4 divided by B4 plus B square C square plus C4 is equal to A square upon C square. Oh, wait, we're only looking at the LHS for now, so you can ignore this bit. So let's see how we'll go about solving this. Again, either substitute A or substitute B. In the numerator, I said substitute A because in the denominator you will have to substitute C because B because C doesn't have any that you can substitute it into. So that's why simply substitute A here. A is equal to BK, so this is BK to the power 4 plus again BK whole square times B square plus B4. Now do the same for B in the denominator. So B is equal to CK. So you have CK to the power 4 plus you have B square, which is CK square times C square plus C4. Okay. Now if we make this equal to sign and we simplify this, let's just write out B4 K4 plus B square K square or B square K square, and that's a B4 actually there. Yeah. Plus B4 divided by C4 K4 plus C4 K square plus C4. Okay. Now you've gotten this. Let's run. Yeah. Okay. And now if we take B4 out common from the numerator, we get B4, which is K4 plus K square plus 1. And denominator, if we take C4 out common, we get K4 plus K square plus 1. Cancel out the like terms, and you get B4 over C4, right? And B, we wrote it as CK, right? So this is CK to the power 4 by C4, and this just leaves us with K4. So our LHS is equal to K4. Let's write it down here. LHS equals to K4. Now, let's move on to the RHS. RHS is simply A square by C square, right? Let's simply prove that A square plus A square by C square. RHS. A was equal to BK, right? So we write that as BK square by C square. And we know that B is equal to CK. So substitute B by CK. So you get CK times K whole square by C square. And if you further substitute this, you get C square times K4 by C square, and you get K4. So your LHS equals RHS equals to K4. Okay. This is how you have to move along with them. Now let's move on to the next question. Okay, let's now move on to the next question. This is one of the toughest questions in this chapter, and I don't think this would ever come in any examination, but I think you should still know how to solve it. So it's similar again. Your A is equal to BK and your B is equal to CK. I'm not writing down the same steps again. And now, okay, in such a case, you see a negative power here. And whenever you see some like lots of confusion, different things happening, it's always better to just first simplify this algebraic expression. So if I look at the LHS, it's A square minus B square plus C square divided by a to the power minus 2 minus b to the power minus 2 plus c to the power minus 2. Now we want to get rid of the minus 2's, okay? We just want to get a simple algebraic expression. So what do we do? Let's say that says a square minus b square plus c square. And as you know, to get rid of a minus sign, you just make it 1 by a square minus 1 by b square plus 1 by c square, right? And if we further simplify this, make the denominator equal, you get a square minus b square plus c square divided by b square c square, making the LCM a square b square c square minus a square c square plus a square b square, and this is divided by a square b square c square. Now we can send this upstairs and simplify this more. You can get a square minus b square plus c square divided by a times a square b square c square, and this expression divided by this expression divided by b square c square minus a square c square plus a square b square. Now, the reason why I said this was tricky is because the trick I told you in the beginning, it won't work here. And one way you can see it is you're adding a c square term here, okay? And over here as well, you're doing that. You were doing that here. So it's very difficult to just change one of them. You have to change both because there's an addition of a c square here. So let's try to get everything in terms of c. Okay, so let me just, so that I don't have to keep doing it. I know my a is equal to bk, right? And my b is equal to ck. So a is equal to ck square, right? If I put b ka value is ck, a is equal to ck square, right? So for now, we're just going to use these two right here, okay? And using these two equations, we're going to simplify this further, okay? How will you understand when to do this? As I said, if you see a plus c square here, or if you try to follow my method and you can't do it, then you just come back and try to do something new, and then you will follow this, okay? So let's further simplify this. A square is equal to ck square. So, okay, I'm just going to solve this slightly faster, so I'm not going to write down each and every step. So a square will be equal to c square k4 minus b is equal to c square, so b square is equal to c square k square plus c square, right? Times a square, again, c square k4, b square, c square k square, and c square, right? Make the multiplication signs. Okay. Now, once we have this, let's do the same for the denominator as well once. B square, c square k square, c square times k square times another c square, minus a square is equal to c square k4. So c square times k4 times another c square. A square, again, c square times k4 times c square times k square, b square, right? Now, it's very easy to make a mistake here, so try to avoid doing that. From here, as you can see on top, you can take c square out common from each term. So let's do that, c square, and you get k4 minus k square plus 1. And then if you simplify this, you get times c, c is 2, 4, 6, so it's c6. And k is also to the power 6, right? And now let's just get rid of the c here and make this c to the power 8 right here. So we can just directly write that. Okay, this is a completely simplified numerator. And now a denominator is, once again, you can see that you can take, okay, let's first simplify it. So you can see that c4k square, right? Minus c4k4 plus c4 times k6, right? Now let's take c4k square out common from the denominator. Let's do that. Let's first write the numerator k4 minus k square plus 1 times c8 k6. Okay, divide this. And you will see that if you take c4 k square common term out, you'll get 1 minus k square plus k4. And if you see this, it matches exactly with this, right? Minus k square plus 1 plus k4. Cancel these out. And now if you simplify this, you get c4, 8 minus 4, and k4. Okay. This is our solution for the LHS. Okay. Now our RHS is b to the power 4. b to the power 4. B is equal to ck, so it's ck to the power 4, which is c4k4. LHS equals to RHS equals C4K4. One of the trickier questions you will find, and I'm saying this because it may not be this easy to directly see what you have to do here. And trust me, I have circled this. It's circled in my book. It means that I genuinely could not solve it, and I had to keep trying until I got it. So let's go to the next question now. Second. And just finding the next question. Okay, yeah, there it is. So copy and let's move on. There we go. And let me just paste the question right here. So here we go. We've been told that x by a equals to y by b equals to z by c, and we've been asked to prove this complex looking equation. But this is not a very tough question, and I'll just show you why. It may look tough because you see to the power 3 by 2, but everything simplifies really nicely. So once again, x by a equals y by b equals z by c, and we make this equal to a constant k. So x equals ak, y equals bk, and z equals ck. Now you have this in place. Let's work with the LHS now. What is our LHS? Our LHS is a square x square plus b square y square plus c square z square divided by a cube x plus b cube y plus c cube z to the power of 3 by 2. Okay, again, what have we written x as? We've written it as ak. So a square times ak squared. B is written as, what have we written y as? We've written y as bk. So it's b square times bk whole square plus c square times what have we written z as ck. So zk a whole square. And this is divided by a cube x is again ak plus b cube y is bk plus what is it? C cube times ck, right? And this whole thing is obviously raised to the power of t over 2. Now, if we go about to simplifying this, this becomes there are two powers of a here, so it becomes a4 times k square plus again b4 times k square plus one second, have we done something wrong? Z is equal to ck. Yeah, exactly. I was just wondering why there wasn't. Yeah, there we go. Plus c4 times k square. This is divided by a4 times k plus b4 times k plus c4 times k, whole thing raised to the power of 3 by 2. Watch how easily everything simplifies. Now if I take k square out common from the numerator, you get a4 plus b4 plus c4, and the denominator, if you take out k out common, you get a4 plus b4 plus c4. Cancel these out and you get this as k to the power of 3 by 2, right? Have we missed something? No, doesn't reflect it. Okay. Now we've got our RHS. RHS is root xyz by ABC. RHS is root xyz by ABC. And what had we written? Our x as x was AK, y was BK. So again, x is AK, y is BK, z is CK. This is an entire square root divided by ABC. This is what? ABC times k cube square root. Oops. Divided by ABC. And now if we take k out common, k outside. 1 second. Is there something we've copied wrong? Oh yeah, I was just wondering why that wasn't working. This under root is actually the entire thing, which is why everything wasn't canceling out like I expected it to. So let's just rewrite this once. It's XYZ. Yeah, now everything works. So X we wrote as AK, right? X is AK. Yeah. So it's AK times BK times CK as we already written, divided by ABC and an under root of this entire thing. You can cancel out the ABC with an ABC and you get k cube square root. And now, as you already know, if you were to take a square root, you can also write it as k3 to the power of 1 over 2. And that gives you k to the power 3 over 2. And there we go. LHS equals RHS, which equals k to the power of 3 over 2. Now we can move on to the next question. Okay, there are two parts here. Again, slightly complex looking, but nothing too difficult, I would say. And A, B, C, and D are in proportion, so we have to prove something. Let's start with part one. Now we can move slightly faster. And okay, over here for the first time, we've been exposed to they're just in proportion, not in continued proportion. So in such a case, same process, but A by B is now equal to C by D, which is equal to K. So now my A is equal to BK and my C is equal to DK, right? Once we have this simple process, simplify LHS. LHS A plus B, A is BK. Don't change B like I told you in the beginning, change only one of them. C is DK, and your D is just D. And if you further simplify this, take B out common, you get K plus 1. Take D out common, get K plus 1. Cancel them out, and you get B over D. Okay? Square this, and let's solve the RHS. Okay? RHS is, what is the expression for it? Under root of 2a square plus 7b square. Under root of 2a square plus 7b square divided by 2a square plus 7b square, 2c square by 7d square, right? If we simplify this, a is equal to what? Bk, right? So 2 times bk squared plus 7b squared, again, no change here, divided by 2 times c is equal to dk, so it's 2 times ck whole squared plus 7d squared, and it's an under root of the entire thing. Okay, and now if we simplify this, we get 2b square k square plus 7b squared divided by 2c square k squared plus 7d squared. Am I right? Yeah. And oh, 1 second. Once again, it's not ck is actually a dk here. C is equal to dk. Well, we can change that to d square. Right. And if we take b square out common, we have 2k square plus 7, right? And on the denominator, we have, if we take d square out common, 2k square plus 7, cancel them out, b square by d square, which is the same as we got for our, oh, 1 second, where have we gone wrong? Oh, b square by, where have we, oh, wait, there's an under root sign here, which we forgot about. So once we get this, and if we get this, that equals to just b over d, and our LHS equals to our RHS equals to b over d. And we've proved this one as well. Okay, nothing too complex. And let me just can copy the same thing once again. So because for the part two, so we don't have to scroll up that much. Second, yeah, let's paste it around here. And yeah, okay. Part two is again same thing. We know that A is equal to BK and C is equal to DK, right? Now let's solve the LHS. This time let's not forget the root sign. So it's root of A4 plus C4 divided by under root of B4 plus D4, right? Now, again, when it's a root of, we know this, right? Root of A by root of B equals under root of A by B, right? We're going to be using this property here to solve this one here. Okay. So, what is A4? A is equal to BK. So, A4 is B4, K4. What is C4? C4 is D4, K4. And yeah. And now, once you divide this, you get B4 plus D4, and with the property I already told you about, you can take a common root and take K4 out common. You get B4 plus D4, and you get B4 plus D4 downstairs as well. So you can cancel them out and take an under root of it. So you get this equal to K square. Okay. LHS equals K square. And with RHS, let's do the same process there as well. It says that MA square plus NC square. So MA square plus NC square, MA square plus NC square by MB square plus ND square by MB square plus ND square, if I'm not wrong. MB square, ND square, MA square, NC square. Okay, what is our A equal to? Our A is equal to BK. A is equal to BK, right? Yeah, A is equal to BK. So M times BK squared plus N times DK squared, because that's what C is equal to, divided by M times B square plus N times D square. No need to change anything here. If you simplify this, you get M B square K square plus N D square K square divided by M B square plus N D square. And if you simplify this, take K square out common, K square times M B square plus N D square. And this is divided by what we require, MB square plus ND square. Cancel this out and you get K square. And your LHS equals to RHS. LHS equals RHS equals to K square. And there we go. So, okay. So, the process which I told you for continued proportion, as you may have noticed, does not always hold true for proportion, normal proportion. For continued proportion, I told you if it's a numerator and a denominator, only change one of them. But in proportion questions, generally, it's better to change both of them directly. Like over here, I made A and C, I changed them to their respective parts and I sold them. Nothing too tricky here. And with this, I think these are enough examples that we need to cover. Solve the exercise, and I'll come back with the next video on the different types, componendo and dividendo and all of that. So thank you and have a great day.